Okay, so let us continue now our discussion. So just give me a thumbs up. Just to let me know that you guys are already ready or already in front of your computer. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, okay. At least maybe 80 to 90% of you were already in front of your computer. Okay, so another example here is find the current flowing around the following circuit using Kirchhoff's current law only. Well, to be exact, you can just add this one and then make it in series connection, and then from there you can already get the I total if you're going to use the Ohm's law. However, it is requiring us to use Kirchhoff's current law only. Okay, so from here, of course, we're going to use Kirchhoff's current law only. So I total is the total current flowing around the circuit driven by 12 volts. Okay, supply voltage at point A. I1 is equal to I total. Thus, there will be an I1 times R voltage drop across R1. Okay, wherein at this point, we could say already that I total is equal to I1. Okay, wherein your I1 will be divided to 2 again. So we could say plus I2 plus I3. Okay. Well, anyway, it's like, having three split currents equal to your I total. So the circuit has two branches, okay, three nodes, which is B, C, and B, and two independent loops. Thus, the I times R voltage drop around the voltage or the two loops will be this one and that one. So ABC and then ABD. So how did we get that one? So let me just get this one so we can draw the loops that we have. So we have two loops in total. So we can actually have the first loop, okay, inside. Okay, so it will pass through this IT, R1, R3, and then going back to our voltage source. And then we can have another loop outside. Okay, so let's call this one A, B, D. Okay, and then the loop outside is A, B, C. Okay, so let's have a loop first on ABD first. So the inner loop. So KVL uh, loop 1 or ABD rather. So in here we have positive 12 volts. Okay, again, I always go with the leading signages. So positive. So we have here positive, negative, and then positive, negative. Okay. So your signages must be always correct because if this one is already negative and positive, then at the very first your answer is already incorrect. Okay, so again, if it will pass through the resistors, of course, it will be a voltage drop. So that is why we have negative in here. So negative I1 times R1. All right, and then right here it will pass through I3 minus I3 times R3. And then going back to its original voltage source, it's now equal to 0. So 12 minus I1, so R1 is 4, I1 times 4 minus I3 times, so R3 is 12, is equal to 0. So this is now your equation ABD. Okay, so if you're going to have another loop, KVL at loop AB, so I forgot to put C in here, ABC. Okay, so in here we still have positive 12 volts and then minus uh, I1 times R1 and then minus I2 times R2. Okay, is equal to 0. So 12 minus I1, R1 is 4, and then I2 and R2 is 6. So from here, this is already your equation A, B, C. So if you guys are going to compare this one on our presentation, so we have the same. ABC is 12 is equal to 4 I sub 1 plus 6 I sub 2, okay, which is this one. And then for the ABB, so we have 12 minus I sub 1 times 4 minus I sub 3 times 12, which is the same with this one. So 4 and 12, and then another 12 right here. Okay, it's just that this one was already transposed, but this one is not yet. Anyway, so from there, we can already solve for the I1 and not yet. Okay, so I1 times I3. This one is I1 and I1, but we will have two another unknowns, which is I2 and I3. But from here, we can actually already eliminate that one and then come up with another loop. Anyway, so let's see what I did in here. So since the Kirchhoffs current states, all right. So we forgot. Okay, we forgot the KCL. So we have to perform KCL first because that is the one that we can use, to eliminate those given variables like I2 and I3. So KCL, let's see at loop B. Okay, at loop B. Okay, at loop node B to be exact. Okay, so from here we have I1, which is going in, and then I2 and I3, which is leaving. Minus I2 minus I3 is equal to 0. So from here, I1 is equal to I2 plus I3. And then from here, we can actually use this one, I1 is equal to I2 plus I3, to substitute it in here, just to come up with I2 and I3 alone. So from here, we can have 12 minus, so I1 will become I2 plus I sub 3 multiplied by 4 minus I3 times 12 is equal to 0. Okay, so this is your ABD. And then from here, you can again substitute the value of your I1 in here to have the value of I2 plus I3 multiplied by 4 minus I2 times 6 is equal to 0, which is now this is your A, B, C. And then we can simplify this one more by distributing the value of your 4. So 4 I sub 2 minus 4 I sub 3 minus 12 I sub 3. Okay, so I've just interchanged the position of your resistor and currents. So the same with here, 12 minus 4 I sub 2 minus 4 I sub 3 minus 6 I sub 2 is equal to 0. Oops. Alright. So from here, we can actually add this 2 I sub 3 in here. So it will give us 12 minus 4 I sub 2 minus 16. So 4 plus 12 is 16. 16 I sub 3 is equal to 0. And on the other equation, so 12 minus 4, so we have 2 I sub 2, 4, and then negative 6. So this one will become negative 10 I sub 2 minus 4 I sub 3 is equal to 0. And then from there, we can actually already perform simultaneous equation using our calculator. Okay, so let me get this one right here, and the same with this one right here. Okay, so in my case, to make our life easier, I will solve it using my calculator. Well, to avoid confusion, you can transpose this one on the other side. Okay, wherein this will give you. Okay, let me just per perform another uh, transformation or simplification. So from here we have negative 4 I sub 2 minus 16 I sub 3 is equal to negative 12. Okay, and then this one will become negative 10 I sub 2, and then minus 4 I sub 3 is equal to negative 12 also. And then we can now use this one to solve for the I2 and I3. So we have negative 4, negative 16, and then negative 12. And we also have negative 10, negative 4, and then negative 12. So for the I sub 2, we have 1 amp. And for the I sub 3, okay, we have the 0.5 amps. Okay, so let's see. Okay, so this is the simplified equation of the ABC and then simplified equation of ABD, which is just the same with what we did in here. And the answer for the I2, oops, yeah, I2 is 1 amp. Okay. And where is our I3? I3 is 0.5 amps. Okay. So in here, it used what we did a while ago, the manual simultaneous equation. So it multiplied by 4, multiplied by 10 to eliminate the I2 for you to be able to get the I sub 3. So the same with this one, it multiplied by 4, it multiplied by 1 for it to eliminate the I sub 3 and then to solve for the I sub 2. But in my case, just by using, those two equations, so, without going to having this manual computation, we'll come up with the same result. So 0.5 and then 1 amp for the I sub 2. Okay, so did you guys get the idea of this one? Hello, hello.
Yes, sir.
Yes, sir.
All right.
Yes, sir.
So to make it clear, guys, kapag wala kayong calculator, ito talaga yung gagamitin nyo. Okay? Mas mahaba. But if you have a calculator, you can just use your calculator and then you can say on your paper, solve using calculator simultaneous equation, and then just put there the value of your I sub 2 and I sub 3. Okay, so I really recommend using your calculator, kasi nandito na nga siya eh. And legal naman siya kasi nga nasa calculator naman. So yung mga illegal, yung mga wala sa calculator. Well, it's a different story already if you have a very advanced calculator. Okay, so I think FX991EX class Wiz is allowed, but the other, let's say, I don't know, they call, is that, I forgot the name, Smart ba yun? But that's a different calculator wherein it's very advanced, wherein you can even store formulas, you can store values, etc., etc. But in here, it's fixed whatever it has, then you can use that one legally. Okay. All right. So yeah, from there you can already solve for the value of your I sub 1, wherein going back to our first KCL or first equation. So I1 is equal to I2 plus I3. So 1 amp plus 0.5 is 1.5 amps. Okay. So from there we have already solved the individual currents of this circuit right here. Okay. And then you can verify that one using Ohm's law, of course. Okay, so you can simplify this one first, and then you can already get the IT, and then you can get the value of the current here first before you can get the value of the current right here. Anyway, so yeah. And then we have here another explanation when it comes to KVL. So again, it's the summation of voltage equal to 0. So R1 plus R2 is equal to 0. And so this one is just a combination of Kirchhoffs and then Ohm's law to be exact. So we have this voltage source plus minus I times R1 plus minus I times R2, which is purely KVL for now. And then another KVL, another KVL, another KVL. However, in here, we can actually, simplify this one just by having the uh, Ohm's law. Okay, if you guys are going to take a look at this was the same with what we have in Ohm's law. So V times IR. Okay, wherein of course if you have the total voltage, you also have the total current and then the total resistance. Wherein total resistance is R1 plus R2. And then from here we can have another equation which is a combination or which was derived from KVL. Okay, wherein this one now is a combination of Ohm's law. Okay, so we have RT is equal to R1 plus R2, and then I is equal to V divided by R. Okay, wherein of course your R is R1 plus R2. Oops, what happened? And then from here, if you want to get the voltage drop of the R1, so you need I1 times R1 or I times R1. And then from here, you can change this one from I is equal to V divided by R. So we have Vs and then your uh, divided by R, okay, which is R1 plus R2. And then we can come up with, again, another voltage drop for the, let's say, R2, okay, coming from here. Anyway, uh, not that much important. It's just that it is saying that you can combine the idea of the KVL and then the Ohm's law at the same time. All right, so let's have this last example, I guess. Yeah, last example. Where is that one? Example number 4. So we have three resistors of values 10 ohms, 20 ohms, and then 30 ohms, respectively, are connected in series across a 12-volt battery supply. So the question here is calculate the total resistance, the circuit current, the current through each resistor, the voltage drop across each resistor, and verify that using a Kirchhoff's voltage law or KVL if you have the same result. Okay, just by using Ohm's law and then KVL. Anyway, so since they are in series, you can just simply add everything. Okay, so R1 plus R2 plus R3, it will give you 60 ohms. Okay, and then for the total current, just use the I. Okay, I is equal to V divided by R. Okay, so voltage source is already given, which is 12, and then total current is already solved, which is 60. So 12 divided by 60, it will give you 0.2 amperes or 200 milliamperes. Okay, so I will not explain this one anymore since it's very simple and very easy to understand. And then for the current through each resistor, since we are in series, so of course your IR1, IR2, IR3 is just equal with your total current, okay, which is 0.2. Okay, that's already it. And then for the voltage drop, so you can use VR1 is equal to I times R1, VR2 is equal to I times R2, wherein it will give you this result. So 2, 4, and then 6. And then from there, we can verify that using, a KVL. So if we are going to draw this one, we have Vs right here, another resistance right here, another resistance, and going back here. Positive, negative, positive, negative, positive, negative, positive, negative. So of course, you will have this kind of loop. So positive Vs minus I times R1. This is your R1, this is your R2, and this is your R3. So sorry for my messy drawing. Anyway, yeah, just to give you guys the graph on how did we get that one. So we have this formula right here. Okay, Vs is minus I times R1 minus I times R2 minus I times R3. Notice that, our I didn't change because as you guys may all know, I1 is equal to I. I2 is also equal to I, and then I3 is also equal to I. So from that, or from there, you can already have this kind of equation, okay, which is now the same with this one. And then just substitute, their corresponding given values. So I is 0.2, R1 is 10, up to the last, and then you will get this one. And if this one is 0, then meaning your answer is correct, okay, or your current is correct, okay, which is 0.2. So from here, 12 minus 2 minus 4 minus 6 is equal to 0, wherein 0 is equal to 0, okay. So were you guys able to get this one so far? Hello, hello. So clear, uh, or at least 50% maybe? What about the others? Mr. Tanikala, Miss Paklauna. Okay, good. Mr. Zosimo, okay, good. Mr. Giano, Mr. Jasper, Miss Maxine, Mr. John David. What is the meaning of clap? Is that a compliment? Okay, alright. Okay, okay, okay. So you can just watch this one again. Well, the main examples when it comes to KCL and KVL is the example number 1 and example number, or is that one? Example number 3, I guess. Yeah, this one. And then the rest is, of course, with the use of, or with the help of Ohm's law. Okay. Well, just to give you guys again a summary, okay, when it comes to solving for the KCL or KVL, okay, so you need to put all the labels first. So VR1, R1, R2, voltage source, okay, and then the next thing that you need to do is, put the polarities, okay. So meaning, is it positive, negative, or negative, positive? Okay, so just be consistent. Okay, if you're going to use positive negative all throughout, or negative positive all throughout, just be consistent. So the same with, choosing the method or the flow of current that you're going to use. So in my case, I always go conventional. Okay, so it's up to you. You can go uh, conventional ba tawag doon? Or electron method. So conventional method or electron method. So it's either clockwise or counterclockwise. Okay. And then after that, you can now perform KCL, first law, and then after that, KVL, the second law. I forgot to put the loops. Okay. So after putting the loops, then you can now perform this one. And then from here, simultaneous equation. Okay. So you can do it manually or via calculator. Mostly the one we are solving for, when it comes to KCL or KVL, are the individual currents. So mostly, whatever is your first equation, that is mostly the source of the answers on that question. So I1, I2, I3, or even if you have I4 and so on. So, okay. So yeah, that's it for the Kirchhoffs law. So yeah, just the final graph for this example, and then more uh, conclusions regarding Kirchhoff's voltage law. And then this is the reference where mostly I've got this presentation of mine. So yeah, that's it for the Kirchhoff's law. And then I have already posted, I mean not posted, I have already published the quiz on your Kirchhoff's law. So the due date of this one will be on May 24. So the same with the Maxwell, which we are going to discuss right now. So let's try to finish this one as quick as possible. All right. So basically, when we say Maxwell, it's super the same. Actually, it's 90% the same with the Kirchhoffs. It's just that there is one thing that mesh or a Maxwell loop is much more better when it comes to solving complicated circuit. That is because it is only using. Okay, later on I'll discuss that one. Okay, so first, Maxwell loop current method or mesh analysis was or we very widely use discrete classes technique in Maxwell loop current method. First, when okay, mali yata to. So supposedly I will say that this one is also widely used when it comes to solving complicated circuit analysis. So it's quite the same with the Kirchhoff's law. Okay, so we also have that law because we wanted to solve a super complicated circuit. So we cannot solve that one just by using Ohm's law. But in here, it's quite the same, but it doesn't deal with loops just like what we have a while ago. So what we're dealing with when it comes to Maxwell is meshes only. Okay, so the very first step that you need to do is identify all the meshes of the circuit. Okay. Anyway, so yeah, this is the guy who founded or who was able to found that idea about Maxwell loop current methods. Of course, came from his last name, James Clerk Maxwell. And yeah, so the mesh current method, also known as the loop current method, is quite similar to the branch current method. Okay, so let me just clarify this one. Okay, so when we say max, okay, let's start with Kirchhoff's first. Kirchhoff's law. So the other terminology of this one is actually, what is that one again? Branching method. We call this one branching method. So those two are just the same. When we say Maxwell, so Maxwell method, we call this one current method or mesh method, or even mesh analysis actually. Okay. So we have a lot of terms for this one. But for Kirchhoff's law, sometimes we call that one branching method. But for the Maxwell, so sometimes we call that one current method or mesh analysis or mesh method. Okay, which is this one or loop current method actually. So we have another name, loop current method. Okay, but for the branch current method, so that one is actually the one that we're using when it comes to Kirchhoff's law, the KVL and then KCL. So yeah, it says here that it's super similar. Yeah, well, in fact, it's 90% similar with the KVL and KCL. It's just that it differs from the branch current method in that it does not use Kirchhoff's current law. Okay, so in Kirchhoff's law, so we are using KVL and KCL. Okay, but in Maxwell, it's only using KVL. Okay, and only dealing mesh loops, okay, or meshes na lang, parang di confusing. Okay, so basically that's the main difference. So this one is using KCL, but in Maxwell, KVL only, and then it's only dealing with meshes. So in here it deals both loops and meshes. Okay, anyway, that's their main difference when it comes to solving unknowns. Okay, so of course, in here we also perform simultaneous equation. Okay, so let's have this example. So let's see how this method works on this example problem. So we have voltage source in here, another voltage source, and then we have three resistors. So R1, R2, and R3. So the first step in the mesh current method is to identify the loops or the meshes to be exact within the circuit encompassing all components. So in our example circuit, the loop formed by B1, R1, and R2 will be the first, which is this one, B1, R1, and R2. And the second one is of course B2, R3, and R2. So let me just have this one. So from here we have this first loop, okay? And then right here we have the second loop. So I've used your conventional method because we have the positive right here and the negative. So in my case, the one that is dictating the flow of current is always the voltage source. So the reason why I have this flow of current right here or this loop right here because of this voltage source. Okay, the same with this one, we have positive and negative. So it's only natural to have this kind of flow of current. So that is why we have the electron method right here. Or actually this one is not electron because it's still going from, leaving from positive. It's just that we can say that this one is anti-clockwise or counter-clockwise. Okay. Anyway, so those two are already our, those two are our already our meshes. So loop 1 and loop 2. And then from here, gets its name from the other getting between spinning gear symbol. Yeah, these are just other ideals. I mean ideals. Call this one. Yeah, ideas before on how did they come up with mesh analysis because of this spinning gears. Just like something like I1 is like the first spinning gear, and then I2 is the second spinning gear. Okay, and then we have here a note. So same process with the KVL a while ago. So note how currents I1, so this is your I1, and I2 are both going up through resistor R2, where they mesh or intersect with each other. So if you guys are going to take a look at this one, so we have a current flowing in here, we have a current flowing in here. So this is, see here, node A, and then we have a current, that will leave that one. So as you guys can see, I1 and I2 have the same flow of current. So in that case, we could say that I1 and I2 will be combined as your I3. Okay, but in here we only have two currents to be exact. Okay, I1 and I2 only. So this is your I1 and I2. All right. And the next step is to label all the voltage. So we already have the labels, which is this one, negative, positive, positive, negative, and right here is positive, negative, and positive, negative, positive, negative. Okay, so after labeling, okay, putting all the labels of your resistors, then you can now perform Kirchhoff's voltage law. Okay, so let's just come up with our own equation because in there's a lot of explanation wherein I will skip those so that we can save more time. So for the loop 1 KVL, so again we don't perform KCL in mesh analysis, so we go straight with KVL. KVL at loop 1. So we have positive 28 volts minus 4 times I1. Okay, and then right here we have minus 2 times R2. Okay, my bad. Okay, so in here we should already uh, uh, the one that I wrote a while ago is R2. So this one is incorrect. The one that I should be writing is I2. Okay, anyway, so in here we have two currents that is dealing with this path. So as you guys can see, we have the I sub 1 and I sub 2. Okay, so that is why we're going to write I sub 1 plus I sub 2. Okay, so if this one is in uh, Kirchhoff's law, okay, we're going to have I1 plus I2 is equal to I3, wherein, I1 plus I2 will come up with another current, which is I3. But in mesh analysis, we don't do KCL, so that is why we don't have I3 in here. So instead of writing I3, we will have this I sub 1 and I sub 2 to be substituted in this expression in here. Okay, so that is the reason why we have this I sub 1 and I sub 2. Okay, and going back to the main source is equal now to 0. So this is now your KVL or your equation number 1 from loop number 1. So if you're going to have another loop, so KVL at loop 2, okay, so we have positive 7 volts minus 1 times I2, okay, minus 2, okay, plus I2 plus I sub 1 is equal to 0. So this is now your second equation. Okay, so from here we can already simplify this one a little bit more. Okay, but we will continue this one later on since we don't have enough time again anymore. Okay, so we now only have 1 minute. So yeah, let's just meet again on part 4, and then let's try to finish the Maxwell on part 4. Okay, so that we're not going to have a part 5 anymore. Anyway, so goodbye for now and see you guys later.